Hello, this is question 5 on your AES Edexcel sample paper. It's a hypothesis testing question. So you have discrete random variable x is a binomial 0.27, and the first thing they ask us is to find this probability. To find x greater or equal than 16, remember I don't have that in the calculator or in the tables if you prefer to use them, so I have to rewrite the question as 1 minus probability of 1 less than that, yeah? And I can find this in the calculator when n is 40, x is 15, and p is 0.27, and I subtract from 1. I would recommend you to, when you find this value with the calculator, put it in the memory and then do 1 minus the actual value so you don't lose decimals, and then you round to 4 decimal places here, so 0.0509. And this is the first part. Then they say, past records suggest that 30% of customers who buy baked beans from a large supermarket buy them in single tins. A new manager suspects that there has been a change in the proportion of customers who buy baked beans in single tins. Random sample of 20 customers who had bought baked beans was taken. Yeah? The first thing I have to do is to write the hypothesis. So I'm going to write H0 and H1. Remember, H0 is always going to be P. We are testing the probability of a binomial equal. And in this case, my binomial, so I'm testing if the probability is 0.3, not this value, 0.3. P is 0.3. And the alternative hypothesis, or H1, is going to be P greater, smaller, or different than 0.3. And I have to read the question to this side. So they say a new manager suspects that there has been a change. So they don't know if it's smaller or greater, or they don't say, it's just a change. So my alternative hypothesis is going to be with the different, it's going to be two tails hypothesis test. They say, C, using a 10% level of significance, find the critical region for a two-tailed test to answer the manager's suspicion. You should state the probability of rejection in each tail, which should be smaller than 0.05. So to find the critical region, what we are going to do is, as it has two tails, I'm going to find the two tails. So one tail will be finding the probability of x being smaller than a must be smaller than 0.5. That's the probability of rejection when H0 is true. And if H0 is true, that means it's a binomial. We are testing 20 customers and 0.3. Yeah? And the other tail is going to be probability of x being greater or equal than a certain number, smaller than 0.05. I can use the tables or the calculator. So remember, you have the tables in your exam in the formula booklet at the back. So I'm going to use that because this binomial is in the tables. Some binomials, so if this is, for example, greater than 50, you won't find them. Yeah, but in this case, we will. So N20P03. So if you go to the binomial cumulative distribution function to the tables, you look for N equals 20, is here, and then the column that is 0.3 for the probability. So is this column here. I'm going to just mark it so we don't lose it. 0.3 and N20. We are going to work with this N, this column. We need to find the smallest probability, the smallest value that gives me this probability smaller than 0.05. So if you look here, the smallest value, or the first value that gives me smaller than 0.05 is this one, yeah, which corresponds to x equals 2. So this A is going to be 2. And so that side of the critical region is going to be x smaller or equal than 2. Yeah, so smaller or equal than my value. That's the first region, or the first tail of the critical region. Now, I cannot use the tables straight away for the same reason here. I don't have the greater or equal, so I'm going to rewrite the question as 1 minus probability of x being smaller or equal than b minus 1. That must be smaller than 0.05. if I reorganize my inequality, I will have that my probability of x being smaller or equal than b minus 1 is going to be greater, yeah, because I'm taking, if you want to think this is going this way, of 1 minus 0.05, which is 0.95. Again, I go to the tables and find the first value that gives me probability greater than 0.95, which is this one here, and x is 9. This is 9, therefore b is 10. So my second section of the critical region is x greater or equal, x greater or equal than b. So x greater or equal than 10. So my critical region has these two parts, so this one and this one. I'm going to reject, if I have to do a test, anything smaller than 2 or greater than 10. Yeah, those are the critical regions. Then they say find the actual significant level of a test based on your critical regions. So the actual significant level is really the probability of x being smaller than 2 together with the probability of x being greater than 10. So it's the probability of something falling in the critical region, which is smaller than 0.5 and 0.5, but not 0.05. Yeah, so we are going to find that probability of x being smaller or equal than 2, probability of x being smaller or equal than 2. In the table, we found out that it was this one, 0.0355. 0.0355, and the probability of x being greater or equal than 10 is 1 minus probability of x being smaller or equal than 9, so it's 1 minus this value here, 0.9520, 0.9520, and this is 0.048. Yeah, both of them are smaller than 0.05. So together, the actual significant level, or the actual level of significance, actual level of significance is both of them together. So this one plus this one, which is 0.0835 or 8.35%. Yeah, they give us always the significant level in percentage. I would give the answer in percentage as well. And that was D. Then one afternoon, the manager observes that 12 out of the 20 customers who bought baked beans bought their beans in single tins. Comment on the manager's suspicion in the light of this observation. So we are going to make a decision. 12 is in the critical region because it's greater than 10. If it's in the critical region, I have to reject this one and support manager's belief that the proportion is different than 0.3. Yeah? In fact, it looks like it's going to be greater because I have a greater value, or I am in the right hand side of the critical region. So I have to say it was 12, no? 12 is in critical region, therefore I have to reject 8.0, and that means accept H1. So this supports manager's belief. And then the last thing it says, later it was discovered that the local scout group visited the supermarket that afternoon to buy food for their camping trip. Comment on the validity of the model used to obtain the answer to part E, giving reason to your answer. So we are assuming that this variable, and we have it here, this variable is a binomial 20.0.3. Remember, there are 4 conditions for something, so for a distribution to be a binomial. One of them is that the probability is constant, or well, we could say the probability is constant. We could see 2 things here. Really, what could be happening is that the the elements in the sample are not independent because they are all scouts and they are all going in an expedition, in a camping trip. So maybe that's a reason for them having tins or buying singletons. Yeah, so we could say that the probability or just the events are not independent. So not independent, therefore it wouldn't be a binomial. It's not binomial. And if it's not binomial, all the hypothesis testing wouldn't make sense. Yeah, and that's all with this exam question.